Welcome back. In this particular video, we're going to get into the world of concentration. Okay, there's primarily four types of concentration that we would learn. So we are going to learn about concentration. Something that you will use in this course, and when you take the second semester general chemistry class, you'll use it there. If you take organic chemistry, you'll use it then. If you take any other chemistry class, this knowledge extends beyond just this class. So it's very important you really understand the concept of concentration. And there's four primary types of concentration we would learn. One is molarity, okay? And the symbol for molarity is uppercase M. The other one is molality, and it's indicated by a lowercase m. Percent by mass, and the symbol really for this is percent m over m. Don't confuse this with the molality, but it's percent by mass, and then there's percent by volume. All these are very easy concepts. So, you know, it requires not much input from your side. It's just very, very little input. And these are probably the simplest of the math problems you would probably learn. And I mean, this is a little math I have you do because this is important. Like I said, this concept of concentration is not just a primary focus of just this class, but this extends so far beyond the scope of this class that you can use the skill just in any other scenarios you will come across in your life or in other areas where you may take an exam on. Okay, but before we get started on all this, we got to understand something. Okay, most of the chemistry that you probably will see will be wet chemistry or liquid based chemistry, all right, or solution based chemistry is the correct word. Because solid state chemistry, well, you need a X-ray, diffraction, or some other form of solid state instrument to really work with chemicals that are purely in a solid state. Okay, what we would primarily be working with is solution chemistry. I called it liquid because, you know, solution refers to something that's floating, it's dynamic, right? So solution chemistry. But what a solution is made up of? A solution is made up of two components. One is a solvent, and the other is solute. Okay, and we're going to tie the solute and the solvent into a solution for all these four concepts you see written on the screen. Okay, let me get a different color, because I do want to emphasize this idea right here. A solvent is typically present in large quantity. Okay. A solute is typically present in small or minuscule quantities. I shouldn't use the word small, but that kind of works with the large part here. Okay. It's large quantity and small quantity, right? Typically, when you work with, you know, anything in solution chemistry, one is considerably in small quantities and the other one is in considerably large quantity, right? So solution is made up of a solute and a solvent, right? Now let's go understand what the molarity is all about. So the first one we're going to talk about is molarity. Okay. Again, the way I might say it might come across as molality, but again, I've told you that right from day one. You've got to use headphones when you watch my videos. Okay, molarity is indicated by an uppercase M. Okay, and what's the definition? Let's write textbook definition of what molarity is before we break it down into our own terms to understand what it really means. Molarity is amount of solute Okay, amount of solute present in 1 liter of the solution. Keep in mind, it's not solvent. It's just what will get to you eventually if you don't really make the difference between solute, solvent, and solution. Molarity is defined as the amount of solute, whatever be it, okay, present in 1 liter of the solution. Okay, if this doesn't make sense right away, I understand, and that's where you should be. If you understood it, then that's good. But either way, unless we actually work out a problem, none of this will make any sense. Okay, so let's say um, what is the molar concentration. I'm going to be very specific with the way I write this question. Again, I may not repeat the same exact style every time I write it. So what is the molar concentration of a solution, okay, when 20 grams of sodium chloride, NaCl. Now again, we have done naming, so you should know how I got the sodium chloride, but that's not the point of this one. When 20 grams of sodium chloride is dissolved in 250 milliliters of water. That is the question right here. Okay? The first thing you've got to do is to figure out the amount of solute. What is the solute in this problem? It's the sodium chloride. Okay? Water is typically a solvent. So when you mix the sodium chloride into water, you make a solution. Okay? So this is the solute. And this is the solvent. When they mix together, you make a solution. Right? Very good. So how do we get the amount of solute in the first place? Well, first you got to figure out the molar mass of sodium chloride. Again, sodium's atomic mass is 23, and as I've said, from now on, every time we say atomic mass, we're going to consider that the molar mass of sodium is 23. Chlorine is roughly about 35.5, or whatever the value on the periodic table that you want to use. So that'll be about 58.5 grams over 1 mole, right? Again, whenever you want to find solute, or there is alternate way of writing the amount, which is, okay, I'm going to write it as moles of, so let me write the alternate method. So molarity is also, instead of amount, the term that we were going to use is the term that we learned in the previous video, which is moles of solute over 1 liter of the solution. I highly recommend, if you're comfortable with one or the other, it doesn't matter, but if you definitely would understand the second part, then that's important. This is just alternate way of writing it, because moles is something you're familiar with, so I recommend you do this. So moles of solute, right? Moles of solute is something we don't know, but we can figure it out, right? If you know, we know the given information is 20 grams, right? Okay, and there's 1. All we are trying to do is figure out the top part of the formula right here, which is just moles of solute. Here you got grams, and you know the molecular mass is 58.5 grams over 1 mole. We want moles of the solute, which is sodium chloride. That means we just put the 58.5 grams on the bottom and the 1 mole on the top. And what does that give us? Well, that will give us just the moles of solute, which would be 20 divided by 58.5. So that'll be 0.3 0.34 moles. I'm rounding it out, just 0.34 moles. Okay, so we know the top. And 1 liter of the solution, right? Now here's the thing. We are going to assume, right, that the density of the solution itself doesn't change. So what we are going to say is, if there is 250 milliliters of water and there's the conversion is 1000 milliliter is a liter, so 250 milliliters would be what? Would be 0.250 liter, right? I don't think you want me to actually show that, do you? I mean, that's just basic algebra, right? So that's we're going to say that the sodium chloride is completely dissolved and has actually not changed the density of the solution, that the volume of that the density has not changed. What does that mean is you can use the volume of the solvent as the volume of the solution itself, right? We are going to make that assumption. So we know that 1 liter of the solution, right? But we've already converted that to 0.25 liters, okay? It's only the important thing is that you have to have the liter. You cannot put 250 milliliters. You cannot divide this by 250 milliliters because that is milliliters. We want it in liters, right? So we converted the milliliters to liters, right? You don't think it's always going to be 1, okay? That is just 1 liter of the solution. But we're not using 1 liter. We're not using 1000 milliliters of water. We're only using 250. So it's only 1/4 of a liter, so it's 0.25. So now you come back and put it all together. I'm just going to put a block here. So we know the top, the molarity is indicated by uppercase M. The top part of the division is 0.34 moles, and the bottom is 0.250 liters. And that'll give you the units of molarity, which I'm going to come back in the next screen and write it up. So 0.34 divided by 0.250. So that is 1.36, okay? 1.36 moles per liter, or simply 1.36 molar. Both are correct. I am going to actually talk more about this in the next screen. Maybe perhaps we'll work out one more problem just to help understand this concept better. Okay, so let's okay. All right, so let me recapture everything I said in the previous screen here. So molarity is, okay, is the moles of solute. Now I am going to replace the amount with the mole because I think you've all heard me say the word moles prior. So moles of solute over 1 liter of the solution. That's definition. That's not the units. Okay. There are 2 common units for molarity. One of them is, both are acceptable, but I want you to know both because we will use one for just writing a unit and we'll use the other one for calculation. Okay. M or moles per liter. Now, just the letter M is only helpful when you're writing the final answer and write an M right next to it. Okay. Whereas this part right here, this is also an alternate way of saying uppercase M, but this is important because I'm going to show you that when we learn about dilution down the road. Okay, that's not in this video, but down the road, or anything you do with concentration, you've got to know that the uppercase M is this. Okay, so let's go back and do another problem. Okay. Okay, so what is the molar concentration or molarity? What is the molarity of a solution, okay, of a solution when 4.5 grams of calcium carbonate is dissolved in, there's so many things that you have to remember to do one calculation. And I understand it is difficult, but it is possible with practice. Okay, it is possible that everybody can do this in a jiffy if you do a couple of problems. The 4 point dissolved in 150 milliliters of water. Okay, right. So if you're still starting out, your first step would be obviously to write the definition of molarity, because I know that students who've taken this class sometimes have graduated and but not know actually the definition, but they are very fluent in calculating molarity. So that is moles of solute over 1 liter of the solution. Please do not forget this, because I won't give you a definition of molarity on the test. Okay, so you would have to remember this information. So we do need to calculate the moles of solute, and then we have to convert whatever volume of solvent we have into a liter of the solution. Again, we are making the assumption that the density of the solution itself doesn't change. So whatever be the volume of our water, which is the solvent, will be actually the total volume of the solution itself, right? So this right here, folks, is our solute. And water, everyone knows, is a universal solvent, so there's no question. Water can never be a solute. Water can only be a solvent. All right, so that means our first job is to really figure out what is this moles of solute. How do we calculate that? Well, first thing you got to do is figure out the molar mass of calcium carbonate. Okay, calcium, I believe, is 40. I'm rounding. You can use the actual values from the periodic table. Carbon is 12 and 3 oxygen is 48. So that would be 60 grams, sorry, 100 grams over 1 mole. Okay, that's 100 grams, but that's, each of this unit is grams over mole. Keep in mind, molar mass is grams over mole. So when we added them all, it's 100 grams over 1 mole, right? Okay, very good. Now we got to find this, right? So we take our 4.5 grams. Again, we're doing this in 2 parts, but you should always use the given information first. Please don't use 150 for this, because that's in volume, milliliters, and this is in grams. So, and again, don't mix the solute and the solvent. So this is the mass of your solute, and then because the gram is at the top and the molar mass, the grams at the top and moles at the bottom, we want to be able to cancel out the grams. So the 100 grams goes on the bottom and the 1 mole goes on the top. So the grams cancel out, we're left with moles. So it'll be 4.5 by 100. So 0.045 moles. So we just figured out the top portion of the problem. We still have to figure out the bottom portion, right? So we still have to figure this out. And keep in mind, I say keep repeating, this is not an information we have learned, but we did learn it in the previous problem, but we have not learned it yet. So whatever be the volume of the solvent, if that's in milliliters, you got to convert it into liters. Now, if it's already given in liters, which we can look at another problem, then you don't need to do any conversion. But this is, unfortunately, it's in milliliters. So 1,000 milliliter, okay, is a liter. So 150 milliliters would be 150 divided by 1,000, which will be 0.150 liters. So now we know the bottom information, which is this, and we know the top information, which is this. Now we just got to put it into the expression. So molarity equals 0.045 moles. Please write the units next to it, otherwise you'll have no idea what you're dividing what and So liters, and so that'll be divided by 0.150. So it's zero point 0.3 moles per liter. As I said, you can write it 0.3 moles per liter or 0.3 more. Both are correct. This will not help you much in terms of calculations because you would always be using this, and this is only just for fancy. If you just want to say it's 0.3 molar, then you say it's 0.3 molar. All right, let's stop here. I think I don't want the video to get too long. In the next video, I'll share one more example, and then we're going to look at the second case of the concentration, which is molarity. Okay, so let me stop here and I'll come back with another video.